Good morning, friends. So today we are going to discuss about the third presentation on quick review of semiconductors, and then we'll discuss about the power diodes. So this is the in continuation with my previous lectures of introduction to power electronics and requirements of an ideal power switch. This is a content for the subject power electronics, which is in fourth semester of Gujarat Technological University, Gujarat. Right. The learner will be able to recall the basics of semiconductor, and he will be able to understand about power diodes in this presentation. Please keep in mind this presentation or this short video is for a quick brush up of what is there in this content. And for detailed analysis, you are supposed to detail understanding, you are supposed to refer to good textbooks. So let's start with the semiconductors. As the word suggests, it is semiconductors. That means a material that conducts electricity more than insulator, but less than pure conductor. Under specific conditions, semiconductor have the ability to act either as a pure conductor or a pure insulator. A semiconductor can also control the direction of the flow of electrical charge. It can block one direction flow and it can allow the other direction flow of electrons, right? The examples of semiconductor materials are silicon, germanium, gallium arsenide, etc. Silicon is generally most commonly used in power semiconductor devices. Gallium arsenide is used in the solar cells and laser diodes and all other applications, which is not the part of our discussion in this subject. No free electrons or holes in pure semiconductor at 0 degree Kelvin. So at absolute natural conditions, pure semiconductors known as intrinsic semiconductors are more like an insulator. By process called doping, impurity is added to the pure semiconductor and the material is now called extrinsic. It generates either free electrons or holes, thereby it becomes either p-type material if there are holes in it and n-type if there are free electrons in it. A lightly doped material means less amount of impurities added. A heavily doped matlab large amount of impurities are added. These are the devices which we are going to discuss in this subject: power diode, power BJT, power MOSFET, IGBT, SCR, TRIAC, etc. Right? So let's start with the PN junction diode. So PN junction diode, as you can see, is formed by combining P and N regions. When the junction is formed, electrons try to cross the boundary and try to reach the region. Same way, hole tries to go towards the N region. So the narrow region around the junction where the electrons and hole combine is called depletion region, because electrons and holes are depleted from this region. As electrons are lost in the right section, so it becomes positively charged, and the electrons are gained in left side of the junction, so it is negatively charged. So a small barrier potential appears, which stops further movement of electrons and hole from one side to the other. Now, what is a forward bias PS junction? When you apply a forward bias, there is positive supply to P side and negative supply to N side. The depletion region narrows. If the applied voltage is more than the barrier voltage, the depletion region narrows down and the flow of charge carrier takes place when the applied voltage is more than the barrier voltage. This is called forward bias, and this V0 beyond which the conduction starts is called threshold voltage or cut-in voltage or barrier voltage. For silicon, it is 0.7 volt. For germanium, it is 1 volt. Now, reverse bias is the opposite case, where you apply negative supply to P side and positive to N side. So actually, the barrier expands, depletion region expands, and a very small leakage current only can flow in this section. This state is for reverse blocking or off state of PN junction. If very large reverse voltage is applied, then breakdown may occur. These are the practical symbols or the shapes and size of the diodes, power diode. A power diode is slightly different from the normal diode, where P plus and N, when N plus is the substrate on which lightly doped N minus region is formed, and then you have a heavily doped P plus region, right, which is behaving as a anode of it. This drift region basically is for a large voltage blocking capacity. So the cross-sectional area decides the total current carried by the device. Larger the cross-section area, larger is the current carrying capacity. The large N minus drift region is for large reverse braking voltage, reverse blocking voltage rather. And this is the characteristics. So when you apply a forward bias to this diode, as you can see over here, so when it is higher than the cut-in voltage, then the forward current increases, and very small voltage is required for this. Is it not? In reverse direction, you can see almost no current flows until this breakdown voltage. And once the voltage is higher than this breakdown voltage, large current flows. And this is called the reverse breakdown. Similar characteristics you can find in case of power diode, where the cut-in voltage is little higher, it is 1 volt over here. Ideal VI characteristics is shown over here. Features of power diode. So power diode can handle high power and high temperature. Generally, silicon is used for making power diode. Most common use is in rectifiers. It is available with the voltage rating from 50 volts to 5 kV. And current ranges from less than 1 ampere to 4500 ampere, right? But we are supposed to note that it is an uncontrolled device. The turn on and turn off cannot be controlled. It can operate only in first quadrant. When voltage positive, current positive, then only it is going to switch on. It is a unidirectional device. It allows current only in one direction, right? So now this was all about the power diode. We are going to discuss about the power BJT in our subsequent lectures. In this lecture, we have seen the fundamental or basics of semiconductor, quick revision, and a quick review of the power diode, right? So that's all from my side in this session. We'll continue with the power BJT in our next class.